In this video, we'll take a look at how to access mesh geometry with construction script. By doing this, you'll be able to create tools like this where you can connect ropes or cables between different types of geometry dynamically and easily. To begin, I'll start off with a brand new project, and I'll create a blueprint by right-clicking in my content browser and creating a new blueprint class. We'll create an actor blueprint, and maybe we'll just call this something like BP underscore random wire. And we'll open up this blueprint. Once we've opened up our blueprint, we're going to navigate to the construction script tab, or you can also just double click on construction script here in the functions. Once we're on the construction script tab, this is the start of our construction script. And what we're going to do is drag this out and create a network that will start to take a look at the vertices of the meshes that we select and then link cables between random vertices from each mesh. But the first thing we have to do is have an input for each one of those meshes. So we're going to go down here to where it says variables, and we're going to add two new variables. Both of them are going to be set to a mesh. So we're going to click down on the type, and we're going to search for static mesh, and we're going to make it a static mesh actor object reference. And we're going to do that for both of our variables here. So static mesh actor object reference. And we're going to name these variables our mesh A and mesh B, or our two objects that we're going to link ropes or cables between. Next, we'll also make sure we turn on the eye or visibility icon for each one of these meshes so that we'll be able to eyedrop or change these meshes from outside of this construction script or blueprint. So when we place this blueprint in our scene, we'll actually have an option in the Details tab to select or pick our objects, our Mesh A and Mesh B. We're also going to add a couple other variables for controlling things like cable width and cable length. So we'll add two more variables, and we'll call it cable width, and we'll make that just a simple float, so a number of decimal places, and we'll also turn on the visibility for that and the other variable, which will also be a float, but that one will be used to determine the cable length. Next, we'll take our mesh A, we'll drag and drop it into our network here, and we'll say get mesh A. And once we have that mesh A, we'll drag this out, and we need to get the mesh component for what we're going to do next. So we're going to search for get static mesh component, and there it is. And that will make sure it's now a static mesh component. And we'll need that because even after that, we're going to be creating a node here that will get the vertices from our mesh. So after we have this created, we can drag out this execution pin and do get section from static mesh. But the problem is the in mesh, we can't connect to our mesh or the static mesh component because they're not the right type. This is looking for a static mesh object reference. So what we do is we convert it to a mesh component, and then what we can do is pretty much just drag this out and do get number of sections, and maybe we'll have to turn off this context sensitive. There it is, get number of sections. And it will create a conversion to static mesh object reference. So we can actually delete this. We don't need that, but now we can connect it up here. And now we have our nodes successfully created. So now we're feeding this mesh into this get section from mesh, and that will return the vertices, the triangles, the normals, UVs, and whatever info we need. Next, we'll have to get our object in world space, or wherever our object is in the scene. So what we're going to do is get our static mesh component here. We're going to drag it out to get world transform. We could turn context sensitive back on or off. Sometimes you have to turn that off, but there it is, get world transform. And that's what I want. And once I have that, I can take that and we're going to get the actual vertice location. So the next thing we have to do is after this get sections from static mesh, we'll drag this out. We're going to do a for loop, or for each loop. We're going to loop through every single vertex, and we're going to get those vertexes. So that array element we're going to take here, and that's the location of each of the vertices, and we're going to do a transform location and use this world transform for our transform reference here, and that will properly get the location of our vertices in world space in our scene, regardless where our object has been rotated or offset or moved to. The next thing we have to do is figure out what vertices we're going to use as our start and end points for those cables or those wires. So an easy way of doing this, or a simple way of doing this, and there's plenty of ways you could choose that. You could choose it by typing in the specific vertex number or its index, or you can do that based on some other method. You could choose how many random vertices it will select or something. But to keep this simple, what we're just going to do is take the array index of the vertices. So if there's like 1,000 vertices, what we could do is take those numbers of each vertice as it loops through vertice 1, 2, 3, all the way up to 1,000, or however many vertexes that object has. We can take that number and do a modulus, so a percent sign, and I can check if it's divisible by a certain number. So I could do something like 15. And then every 15th vertex will pretty much end up being something that we connect with a rope or a cable. Because what this will do is this will check if 15 is divisible by whatever index we're on. So if it's 1, it's not. If it's 2, it's not. If it's 15, it's divisible by that. If it's 30, it's divisible by that without a remainder. So if that happens, this equals 0. So I could check and do a double equals, which is equals, and check if it equals 0. Is the number that we're on, the index that we're on, divisible by this amount? If it is, if it returns 0 and there's no remainder, well, then what we can do is do a branch, like a if statement, and if that's true, then what we can start doing is setting those as our start points for our cable. We're starting to create our cables at that vertex or that location. So this is our way of just choosing every nth amount of vertexes and using those as our start point and end point. So I'll stick with this, and maybe instead of 15, we'll put this to 100, because if your object has like thousands of vertices, it might end up creating too many cables. So we could make this number adjustable, but I'll start with this. Now, so we have some sort of visual feedback, so we could test if this is working. What I'll do is I'll draw a debug box. So I'll do draw debug box. This is more of a temporary thing, but we'll just draw a red box on the vertices or on the locations that we return here when it's every 100th vertex, and we can have a duration for how long that display stays, maybe 5 seconds, and a thickness, maybe 10 thickness. And this is a way we can test to make sure this works. So if I were to compile this, save this, so if I minimize this and I drag and drop my random wire blueprint into the scene, and maybe I create a sphere, there it is, and I go to my random wire blueprint, you can see I have inputs for mesh A and mesh B, as well as cable width and length. I haven't initialized the cable width and length, they're both at 0. So maybe I'll go do that. I'll go here and set the cable width default to something like 10, and maybe the cable length default to something like 300, and I'll compile and save. Now it doesn't matter right now because we're not using those, but you should always set some sort of default value. So now for mesh A, since I have that connected up to our blueprint, I drop this sphere and we'll see if it creates those boxes on every 100th vertex, and it looks like it does there. So it looks like that's all working. So now what we can do is go back to our blueprint and continue making the rest, since we know that this chunk of our blueprint graph is working and doing what we expect it to do. So now all we really need to do is the exact same thing, but for our mesh B. So I'm just going to take all of this, copy, paste, and this is maybe not ideal right now. We'll clean this up a bit later, but I'm going to take all this, get rid of mesh A, drag and drop in mesh B, connect this all up. So that's our in mesh, and then our world transform. And then right after we do our draw debug box, we'll just have it continue and do our get section from static mesh and do the whole thing again, but with our mesh B. Now that's not really optimal, but we're just doing this to test it first, and then we'll take a step back. So after we draw both these boxes, maybe these boxes for the endpoint will be green or something, just so we can test it out easily, have different colors, knowing the start and end points. What we'll do next is add our cable component. So we'll do add cable component. And when we do this, we have to connect our relative transform location. So what we can do is split this if we want to break it down into the actual just location by itself. And we'll connect that location, that's our start points. So we'll connect it to our locations that we return here, our start points. And then what we have to do is set our cable's length. So I'll do set cable length. The target is our cable component. The cable length will be our variable that we'll drag in here. Set our cable length. Set our cable width. Target is the same thing, our cable component. Cable width will be our width variable. And then finally at the very end here, what we'll do is set the endpoints of our cable. So we'll drag this out and do set cable end location. And the end location will be our endpoints here and our target, which is our cable component. And now we can test this out. So I'll go back, I'll save this, compile, save. We can minimize it. I'll take this sphere, I'll copy and paste it so we have two of them. And on my random wire blueprint, I'll select with the eyedropper mesh A, select with the eyedropper mesh B. Okay, and there we go. And now we see our wires get created somewhere over there. Now I should reset this blueprint random wire to 0. It should always be in the center of the world, so it's not offsetting it. You could probably compensate for that in the blueprint, but in this case, we'll keep it simple. When you drag and drop your random wire blueprint into your scene, just make sure its location is reset to 0, but you can connect these wires or points between really any object, as you can see here. I can just eyedrop and pick whatever objects I want to connect these wires to. And we have controls over cable width, so make them thinner cables. You can make them more loose, longer cable length, or less cable length. So it's kind of controllable. But this all seems to work right now. The only thing is it's not very efficient. So let's clean this up a little bit. So I'll go back in here. I'll open up our random wire blueprint and I'll make some room here. And what we're going to do is fix this up a bit. So right now it's not very efficient because it runs through a full loop. And while it does that, it runs through a full another loop again. And it's doing more things than it should really have to. So instead of running our loops in one continuous strand like this, we're going to disconnect this connection from the draw debug box of our start points, and just instead of continuing to our mesh B points, we're only going to do that at the end. After our for each loop here has completed, then we're going to go do our next meshes loop. And instead of just drawing our debug box, we're going to actually store our locations of the picked start points and endpoints to a variable. So we'll create two more variables. One of them will be called start points. The next one will be called endpoints. They'll both be vectors, so a combination of 3 values. And we're going to hit compile and then change both of these start and end points not to just be a single value, but an array. So we can store multiple items. And then we'll drag our start points in here. After our draw debug box, we'll say, or actually we're going to drag out our start points and do add. We want to add a value to that array. And we're going to add our location of the point. So that's what we want to do. And we're going to do the same thing for our endpoints, our mesh B. So instead of having our cable component and all that stuff here, I'm going to disconnect all that for now. And I will move that somewhere else down below. We'll do the same thing, but instead of start points, we'll do our endpoints here. So we'll add our locations for our start points, our endpoints when we loop through each one of those meshes, mesh A and mesh B. And when it completes, then it does the next loop. So when the mesh B completes, then we'll do our next thing, which is drawing our cable component. But then we have to get the start and end locations. So what I'll do is I'll take my start points, drop that in here, get those start points, and we'll loop through those start points. So we'll drag out the start points and we'll do a for each loop. We'll start this running this loop after we complete setting, all of our endpoints. So after all that's done, we then loop through all of our start points. And what we'll end up doing is adding our cable component, setting the start point transform to our start points, and then we'll have to get our endpoints. And from our endpoints, we'll create a node called get. We can just do get array, and we'll get a reference. The index is what we'll use because there'll be a hopefully equal number of start and endpoints. So we'll use the index as what entry to get from this list or that array of multiple items. And we'll set that as our end location points. And then we have, our cable width, our cable length here. Maybe we can also add in something like control for stiffness. You can add another thing here and say set. You can do set enable stiffness if you wanted to and do a control for that. But maybe I'll just leave it like this for now. So there's a lot of other things you can add. But after doing all that, this is a bit more efficient. It doesn't really change how the tool functions, but maybe it's a bit more quicker. And also, I think it looks a bit cleaner. You could separate these out into comment boxes or things that make it a bit easier to look at. But if we compile and save, we can now go test this out. And here it is. So we can eyedrop from any mesh to any other mesh, from one of these spheres to another sphere. And you can kind of keep chaining that on if we wanted to. Like I could duplicate this sphere again, and maybe I could make this tool a lot better and have multiple cables you can connect. But if I drag and drop another one of these in the scene, reset its position, now go from this sphere to that sphere, there we go. I can set the width and the cable length, and we kind of have our tool. So pretty cool, pretty easy to create, and probably gives you a bunch of ideas for making something even more complex. If you enjoyed this video or you learned something new, don't forget to like and subscribe. And if you're part of the Patreon, which you can find a link to down in the description below, you'll get access to the PDF for this video, which goes over all the steps we went over in a little bit more detail.